Hey guys, what's up and welcome to my course. In this video lesson I'm going to talk about the internal hardware of the DSLR camera. Now you're probably wondering, why do I need to know something like that? Well, it comes in very handy sometimes. Now of course you don't have to know this information to create beautiful videos. But when you do understand the hardware within the camera, you will also understand the problems that comes with the camera sometimes, like a buffer that gets full, or sometimes you are hoping for a firmware update that gives you, for example, 60 frames per second on a camera that can't do that yet. And when you understand the camera, you can know at front if that camera is capable of doing that or not. Alright, so I want to talk about two things in this lesson. The first thing is the sensor of the camera, and the second thing is the processor. Now, these two things work very close together. Let me start with the sensor. So first of all, we have to know how a sensor works. So the light comes in to your lens. That's the first thing, the lens itself. And the lens is going to create an optical image. And that light, that optical image actually, is being beamed onto the sensor. And that sensor is going to digitalize that optical image into a digital image. And that's how it works. Now, it's important to know that a sensor also has to be good. Many people always talk about lenses, and lenses have to be the best, it's the most important thing of your camera, and they always talk about the lenses. Well, actually, I think that the sensor is the most important thing of your camera. Now, of course, today we can't find bad sensors anymore. These DSLRs have amazing, great sensors. But then again, there are many differences in them. But no, don't take me wrong guys, a good lens is also very important. And again, I have a separate lesson about that. Alright, so I want to talk a little bit about the sensor that was very popular before the DSLR cameras. And we can find that sensor in, again, this type of camera. It's the CCD sensor. Now, we have a 1 CCD and we have a 3 CCD. This camera is actually an amateur camera and it only has a 1 CCD sensor. But when we take a look at the professional cameras, like a Sony VX2100 or something, they have this 3 CCD sensor. And the thing what was so great about that sensor was the image reproduction. You know, everybody loved that sensor because the image reproduction from analog to digital was so accurate, you know, it had beautiful colors, etc. And it didn't use that much battery. So the power consumption was way less than the sensor that we can find in the DSLR cameras today. But the downside of that sensor was that it read out the information vertically. So that means when you were shooting against a strong light, you would see these vertical light beams on your sensor or image. And another downside of that sensor was that the image reproduction had to use the whole sensor, so the digitalization of the analog signal. So that means we couldn't stick any bigger sensor in there because video was only standard definition or maybe high definition already. So we only had a maximum resolution of 1920 on 1080, and that had to be the size of the sensor. So when we take a look at DSLRs, they can shoot pictures of 5K, 6K sometimes. Now that's a huge resolution, but we are able to shoot video at almost 2K. That's almost a half or 1/3 of the actual sensor size. So that's why they had to stick a CMOS sensor inside a DSLR camera. And I think that's an advantage because that will allow us to shoot beautiful photos, stills, and beautiful video. Another great advantage of the CMOS sensor is its pixel manipulation. The CCD read out the information first and then it did a manipulation on the whole image. But the CMOS sensor actually did a pixel manipulation, and that means each pixel is being handled separately. Things like noise reduction, exposure, etc. is all being done way better on the CMOS sensor. Now, the downside of the CMOS sensor is its color reproduction. Okay, that was a very strong point at the CCD sensor. Now, since DSLRs are so popular for video these days, manufacturers are really working on that, and today the CMOS sensor is really great. It works very well at color reproduction. Alright, one more thing about the sensors now. We can find basically two different sizes of sensors within the DSLR cameras. The first one is full frame, and the second one is APS-C. Now, what does this mean, and what is the difference between these two sensors? Well, I've got a great image here. When we look at this image here, we can see that the square or the rectangle of the full frame is much bigger than the APS-C. And it's not only like that on your image, but it's physical. When you take a look inside the camera, the sensor is real bigger than the APS-C sensor. So the three biggest differences between the full frame and the APS-C sensor are, first of all, the full frame sensor has a more shallow depth of field. Now you're probably thinking, great, that really looks cinematic. Now be careful. When you stick a 1.2 aperture lens on that, you really have almost nothing which is sharp. It's a very thin line which is sharp. And if you're doing handheld shots, it's going to be very difficult to keep your subject in focus. So when you really want to work on these fast lenses with a 1.2 or a 1.4 opening, then you might better look at an APS-C sensor where it doesn't have such a shallow depth of field. But then again, if you really like to work with that thin line and you're not doing that much handheld shots, well then a full frame camera is perfect for you. The second difference is the light that's coming into the sensor. Because a full frame sensor is much bigger, it can take up more light. So that means it will perform better in low light situations. So that really is an advantage over the APS-C sensor. And finally, we have the crop. Now, what does that mean? And I'm going back to my image right now. You can see that the full frame sensor is a lot bigger than the APS-C sensor. Now, this has a big influence on our lenses. A 50mm lens has the same optical image as our eyes, as the human eye, as we see. If we go under that 50mm, so we are zooming out actually, let's say something around 24mm, then we are looking in a wide angle, something that the human eye can see. When we go over that 50mm, let's say 70mm or something, then we are going in a more telephoto image. Also something that the human eye can't see. We are zooming in. Now, if we stick that 50mm lens on a full frame sensor, then the optical image that comes out of that camera is exactly the same as the human eye, because there is no crop factor. The crop factor is 1.0. That means we multiply the millimeters by the crop factor 1.0, which is still the same, 50mm. Now, when we stick that 50mm lens on a APS-C sensor camera, we do have a crop factor. And it lays somewhere around 1.6. And that means we have to multiply the actual lens focal length, which is 50mm, by that 1.6. And then we end up something around, I don't know, 70 or 80mm. So that means that 50mm lens is a telephoto lens. You have an advantage on when you want to make more telephoto videos, but you have a disadvantage when you want to make more wide-angle shots or maybe even fisheye shots. Then you really need a wide-angle lens on an APS-C sensor to have that wide-angle or fisheye effect. Like on a full frame, 12 millimeters, 16 millimeters is almost fisheye. Alright guys, that's it for the sensor now. The next thing I want to talk about is the processor. So what is the role of the processor inside the camera? First of all, the processor is linked to the sensor. The pixel manipulation like exposure, noise reduction, etc. is being done by that processor. So after the processor manipulated the image to the final product, it writes that information to an internal memory of the camera, and that is called the buffer. And that buffer is writing the information onto your SD card or CF card, your storage, your actual storage card. Now, it is possible when the data rate is too high that the buffer gets full, and then it can't follow anymore with writing that information to your SD card or CF card, and then your camera will just stop recording. You might have seen that already. So the next thing about the Digic processor are its versions. First, it all started with the Digic 1. Then we had 2, 3, and then 4. And that is actually the thing that changed the film industry, the Digic 4 processor. Because that processor was able to shoot video at the H.264 codec. That was the first processor that was capable of doing that. And it was much faster. It had a much better noise reduction. And you can find that Digic processor inside the Canon 5D Mark II. And then when we take a look at the Canon 7D, it has a dual Digic 4 processor inside of it, and that makes it even more faster. And also it has a way better video compression, so we see less compression artifacts, and all of that because of the processor inside of the camera. And today we also have the Digic 5 processor and a Digic 5 Plus processor. And somewhere in March, April, May 2013, the Digic 6 is being introduced. So what holds that for the future? 4K maybe, 4K video, even faster, even better noise reduction, maybe 3D, I don't know. That's up to Canon, Nikon and all those other manufacturers. Alright guys, thanks a lot for watching this lesson. In the next video I'm going to talk about the fallbacks of the camera. There are a bit of problems with the photo camera actually, and I'm going to teach you how to work with them.